Welcome to Chapter 4 of Second Marking Period. In this unit, we are going to learn how to classify classify triangles, and then find the measures of the angles. Please feel free to pause the video and read through these vocabulary and see if you understand it. The only thing that I really want to clarify is exterior angles. Exterior angle says if I have a polygon, in this example I draw a triangle, and I have three interior angles, 1, 2, 3, right? So now it says when the sides of the polygon is being extended, so if I extend that side over there, and then if I extend this one over here, and this one here, and then this one here. So once you extend the sides of the polygon, the angles that form linear pairs, so if this is right next to 2, I put angle 4 there. So 2 and 4 are a linear pair, therefore 4 is an exterior angle. And in this case, I would do 5. 3 and 5 is a linear pair, so angle 5. And I can say the same thing on this side of angle 3. So angle 6 and 3 also form a linear pair. And angle 7 and 1 form a linear pair. Angle 8 and 1 form a linear pair. And angle 9 and 2 form a linear pair. So all of these angles that form a linear pair with the interior angles, those are called exterior angles. The rest of it is pretty much common sense. So let's see how to use them. But before we do that, here is a chart that's a review of middle school concepts. If you need help, please approach me or any of the teachers. We can help you with it, but generally it's pretty self-explanatory. Let's look at this example here. Shuffleboard. Classify the triangular shape of the shuffleboard scoring area in the diagram by its sides and by measuring its angles. So if you look at it on the right hand side, we've got the shuffleboard here, right here. And the solution is right here. The triangle has a pair of congruent sides. So this side, notice that line there. That means these two are congruent. And if you measure the angles, you will find that these two angles are 72 degrees, and this angle is 36 degrees. So this is acute, right? All three of them are less than 90 degrees. So I'm going pretty quickly because this is a review for middle school information. Let me know if you have any questions. Also, pause the video right here and finish your checkpoint example. Here's another example. Classify RST. RST is on the right. Classify it by its size. Then determine if the triangle is a right triangle. So first step, we have to know what kind of triangle is it. Is it obtuse? Is it right triangle? And so on and so forth. So the way we do it is to find the length of each side. In order to find length, because these 3 points, the coordinates are given. Once the coordinates are given, you can use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. Just a reminder, this is not to be confused with a midpoint. Remember, midpoint formula is like taking an average of your grades. If you scored 100 in the first test, 90 in the second test, the midpoint is the average of the two. You add the 2 points together, you divide it by 2. Distance formula, however, is different. You have to measure the distance of all the points. In this case, x first, square them, y distance on the y, square them, and take a square root. The reason you do that is because of Pythagorean theorem. So if you plug in all the coordinates, such as what's being shown here, you will have the length of each sides here, right? Now, so now that you've got the length of each sides, you need to check for right angles. And to do that, you have to find out if it is the right angle, the slope for RT and the slope for ST, if this is a right angle, the slope for RT and the slope for ST would be negative reciprocal to each other. In other words, M1 times M2 has to equal -1. So the way you do it is to use the definition of slope, which is rise over run, right? And that's why they were doing y2 minus y1 over x2 minus x1 to calculate the slope for RT. And for the same formula, they're calculating the slope for, that's M1, but calculate that, it's M2. The slope for ST is 3/2. And if you multiply M1 times MT, you would have -1. Therefore, this is a right angle. Okay, so angle RTS. Yeah, RTS is 90 degrees is an angle. Therefore, RST is a right scalene triangle. Here are two theorems. Again, with those theorems, please do not just memorize them, understand them. The first one says triangle sum theorem. The sum of the measures of the interior angles are, the interior angles of a triangle is 180 degrees. In other words, right here, measure of A, measure of B, measure of C, all the interior angles, you add them up together, is 180. And theorem number 2 is exterior angle theorem. The measure of an exterior angle of a triangle, in this case we're looking at angle 1, is equal to the sum of the measures of the two non-adjacent interior. In other words, right here, measure of angle 1 equals the measure of angle A and the measure of angle B added together. Okay, that makes sense, right? Because if you look up here, let me change the color, angle 1 and angle C together. So measure of angle 1 plus the measure of angle C would equal 180 degrees because they're a linear pair, right? And we also know that angle C, the measure of angle C plus the measure of angle A and the measure of angle B together is 180 degrees. And that's because of the triangle sum theorem right on top. And now we can say the measure of A and B together equals the measure of angle 1, which is that exterior angle non-adjacent to these two angles. So that's the reason. So if you know one, triangle sum theorem, and you all know it from middle school, you should be able to prove the second theorem, which is exterior angle theorem. Okay, let's look at this example, how we can use those theorems. It says, use the diagram at the right to find the measure of DCB, which is right here, is this angle right here, which is 3x minus 9 degrees. Now, we know that by exterior angle theorem, it says the exterior angle of a triangle should be the sum of the non-adjacent two angles. So by that definition, we can set this equation up. 3x minus 9 equals 73 plus x. And if I do a little bit of algebra, I should have my x equals 41 degrees. Be very careful here. We get so automated over the years of practicing to solve for variables. A lot of students tend to stop right here. But notice that you're asked to find the measure of the angle. And the angle is 3x minus 9. So you need to substitute 41 in 3x minus 1. Your final conclusion should be your 3x minus 9, which is the measure for DCB, is 114 degrees. Finally, a real-world application. Let's see how we can do this. Ramps, the front face of the wheelchair ramp shown forms a right triangle. So this is the wheelchair ramp, and the front face is right here. This is the front face, and that's a right angle. That's what it says so far, right? So we've got one piece of information. The measure of one acute angle in the triangle is 8 times. So 8 times. I like to write it out as I read. The measure of the other. So if I want to set this up is whatever this first angle, the big angle is, it 8 times, and if I don't know the measure of the other, I let that equals x. Find the measure of each acute angle. So I have to find the measure of both acute angles. Now, if I let this angle here equal x degrees, my other acute angle would be 8x, right? And let me erase those unnecessary marks. And as long as I have that, now if I use the corollary to the triangle sum theorem to set up and solve the equation, it would look something like this. It would look like x plus 8x equals 90 degrees. And if you solve that equation, you should have x equals 10. And now if x equals 10, obviously, if this is 10 degrees, the other one would be 80. It's 8 times 10. So that's the answer to the other question. Okay, I hope this is helpful. If you have any questions, please feel free to bring it back to class. Thank you, guys.